Hello Pre-Calc. I wanted to show you a quick video with two examples of solving polynomial inequalities. This is a cubic inequality that you see on the screen, and in class we went over some steps for doing this, and the first step is to move all the terms to one side, get 0 by itself. The next step is to factor the polynomial, then find the zeros of the polynomial using the factors of the polynomial and the zero product property. And you're solving it almost as if you are solving an equation first. You want to mark the zeros on the number line and indicate if they're in the solution set or not. That's where you want to start. Then test the intervals between the zeros, and a sign chart can help you do that. There's more than one way to do it, but a sign chart helps organize your work. Okay, so here's one. So it says solve the following inequality, make a clear sign chart. Graph the solution set and write the solution set in interval notation. So let's do all our steps. So I'm going to write the inequality on the left. X cubed minus 2x squared is greater than 3x. Okay, let's do it. So we need to get all the terms to one side. So let's subtract 3x from both sides. And I get x cubed minus 2x squared minus 3x is greater than 0. Now I want to factor. I want to factor the left-hand side. There's a common factor of x in all the terms. And that is a factorable polynomial, a factorable quadratic. And it will be x minus 3x plus 1. Okay, so next we find the zeros of that polynomial expression. Now we are solving an inequality, but it's almost as if you're thinking for a moment that this is an equal sign. So we're finding the zeros of that. And the zeros will be x equals 0, x equals 3, and x equals -1 from each of the three factors. It's a cubic polynomial, and in this case it has 3 real zeros. Next, graph a number line and mark these numbers on the number line. I could have taken time to really space them out nicely, but for the sake of just we don't need to in this case, so we can just mark them just approximately the right distance. Now what I recommend doing right now before you do a sign chart is check whether the zeros themselves make the inequality true. If I were to plug 0 into this inequality, I would get 0 on the left-hand side because there would be a 0 here. And that would be 0 is greater than 0, which is false. So that's an open circle. And similarly with, I spoke about 0, but then I marked it on -1, but -1 will be the same. So if I plugged in -1, it's going to make this 0. If I plug in 3, it's going to make this 0. In any case, all the zeros actually are not in the solution set because this is strictly greater than. What we want to know is what x values make this left-hand side greater than 0. That's equivalent to saying what makes this left-hand side positive. So all we need to do is we need to look at the signs of each. We can look at the sign of each of the factors. What is the sign of x in each of the intervals? What is the sign of x minus 3? What is the sign of x plus 1? And we're going to check it in each of the intervals that we have. And we have 4 intervals. We have the interval to the left of -1. We have the interval in between -1 and 0. And we have the interval between 0 and 3. And we have the interval to the right of 3. So there's 4 intervals here that we need to check. Well, if I pick a number less than -1, like -2, then if I plug that into x, that's negative. So I'm just going to mark that this is negative. If I plug in a number between -1 and 0, that's also negative because I'm just plugging it in for x. So x would be negative because I'm plugging in a negative number. And over here, this would be positive because I'm plugging in a positive number greater than 0. And this would be positive as well. Now, what would happen if I plugged in a number, a negative number to the left of -1, and I plugged it into x minus 3? Well, a number like -2, if I plugged it into x minus 3, would be -5. We don't really care about the value, we just care about the sign. That's negative. If I plug in a number between -1 and 0, -3, that's more negative, so it's still negative. Here's the one to be careful about. If I plug in a number between 0 and 3, that means it's less than 3. If I plug it in here for x, that -3 is negative. Like 2 minus 3 would be -1. So this is still negative. And if I plug in a number greater than 3, x minus 3 is, is positive. Okay, what about the sign of x plus 1? Well, if I plug in a number less than -1, this is negative. If I plug in a number between -1 and 0, and I add 1, it'll be positive. And if I plug a positive number in there, it's plus 1, it's positive, plus 1 is positive. So what is the sign of the whole product? So what is the sign of x times x minus 3 times x plus 1? Well, it's the product of these signs. A negative times a negative times a negative is a negative. A negative times a negative times a positive is positive, and this is going to be negative, and this is going to be positive. So now we need to go back and think. Look at our inequality. We're trying to find when the left-hand side is greater than 0, so we want the intervals where the result is positive. And we can find that it is in here. So the inequality is true in this interval, and it's true in this interval to the right of 3. It is false between 0 and 3, and it's false between -infinity and -1. So our solution set is all the points between -1 and 0, and all the points between 0 and, not between 0 and 3, all the points between 3 and positive infinity. All you have to do is test any one number in those intervals, or just test the sign inside that interval, and that's good enough. That tells you what you need to know. Finally, so we've graphed it. Finally, we want to be able to write interval notation, and the intervals are from -1 to 0, and with parentheses because it doesn't include the endpoints, and we union the interval from 3 to infinity, because that's this one over here, because it goes up to infinity, goes forever to the right. So we've done the graph, we've done the interval notation, and we're done. I just wanted to quickly show you the picture of what's going on in this situation. What you see up here on top is the factored inequality we're solving. What I've graphed below is this function f of x equals x times x minus 3 times x plus 1. And what we can see here is where is the graph above the x-axis? Where is it positive? Well, it's not positive at -1 because it's 0. It's not positive at 0 because it's 0. And it's not positive at 3 because it's 0. But it's positive everywhere between -1 and 0. And it's positive everywhere to the right of 3. And that's exactly what we found up here. I just want to emphasize that the answer here is a set of x values only. So you can visualize the answer as being not the graph itself, but our answer are the x values where the graph is positive. So it's all the x values between -1 and 0 and all the x values to the right of 3. Okay, one more quick example just to show you one thing that can come up. And this one is a little quicker because it's already brought to one side and already factored. So let's do a quick sign chart. So the first thing we need to do is find the zeros of this. And the zeros are x equals 0, x equals 2, and x equals 3. The number line, I can draw a number line and plot the values 0, 2, and 3. Now, the zeros themselves in this case make it true because the inequality is less than or equal to. So I'm going to plot the zeros, but I'm going to color them in because they're going to be included in my solution set. Now I can do a sign analysis, and you notice the first factor is negative x. I want to make sure to bring that along because the negative in front is going to contribute. So I test the factors negative x, x minus 2 squared, and x minus 3. And okay, if I plug in a number less than 0, negative x would be positive because I'm multiplying it by negative 1. If I plug in a positive number, it'll be negative. So these will all be negative. If I plug in a number less than 0, x minus 2 is negative, but you square it and it's positive. Oops. And in fact, no matter what number you plug in, as long as it's not the zeros, it's going to be positive. X minus 3 is negative for the negatives. It'll be negative for something less than 3. And it'll be positive if you plug in something greater than 3. So then the full product, the product of all three, would be negative x, x minus 2 squared, x minus 3, will be negative, positive, positive, and negative. Okay. Now, we look back and say, we want all the values where this is where this side is negative because we want everything less than 0. So we have it that it's true here and, oh, sorry. Yeah, oh no, that's right. True there and true there because we want where it's negative. And it's false here and false here. You don't need to write all this out. I'm being extra explicit for my example. If you have time, it's nice and very clear. And so we want our solution set are all the numbers to the left of this. Our solution set includes all the numbers to the right of this. So our intervals are those. But careful, don't miss the fact that that singleton number 2 itself makes the inequality true. So how do we write this in interval notation? We write this in the following way. We write that our solution set, well, we actually mix interval notation with set notation, so I'll show you. Our interval on the left is negative infinity to 0, and we union a single point 2, and we union an interval from 3 to infinity. So this little singleton set, singleton meaning one thing, one little point, so that's just the single set including 2. This is interval notation because there's infinitely many numbers in this interval, and there's infinitely many numbers in this interval. And if we look at the graph, we can see what's happening. What's happening is the graph is negative everywhere over here, and it's 0 at 0. The graph is negative everywhere over here, and it's 0 at 3, and it just touches the x-axis and turns back. So to the right of 2 and to the left of 2, it's positive, but at 2, it's 0. Okay, I'll see you in class.